Okay, so we've been talking about exponents and logarithms, and we're going to use them finally now that we have enough tools in our bag to solve things that we couldn't solve before. So we're going to be modeling with logs and exponents, okay? So basically I'm going to go ahead and give you an example. So let's just start with that, okay? Let's say we have an investment that we've put our money into, okay? And the details of this investment is that it is going to be compounded monthly. Okay, at 12%. Actually, no, at 10%. Okay? So the question that we have here is we want to know how long it would take. So how long will it take for our investment to be double? Okay? So essentially, what we've learned in the past is that we do have a formula that teaches us how much we can earn after a certain amount of time if it's compounded at a certain rate over so many times throughout a year, okay? So this is the formula that we've used before. P is the principal, that's how much that we started with. 1 is 1, plus the rate, which in this case is 10%, so I'll put R here. N is the number of times that is compounded in 1 year. So the fact that it's monthly, this tells us that N is 12. And T is our time in which it passes. Okay, so the question here is how long will it take for our investment to double? Okay, so if we put in P principal, okay, we want to know how much A would be if it was doubled. So in other words, we want to know how long it would take for A to become 2P. Okay, so I know that we mentioned sometimes people want to put in like a value like 1,000 and 2,000. It's good to keep it general so that, you know, it's true for any circumstance, whatever the principal or investment amount is going to be. So our equation is going to be, if we fill in the rest of the information that we have here in blue, 2P is equal to P. Okay, so if we put in P, we want to know how long it will take for it to be double, so 2P, okay? And then we're going to put in the rate, which is 10%, 0.10, over N, which is monthly, the number of times that it's going to be compounded, and then to the 12T power. Okay, we know it's compounded at N, which is 12, and we're in search of how long it will take, which means the number of years, T. Okay, so if we had tried to attempt this problem at the beginning of the chapter, we actually don't have enough resources to be able to solve for it because we have an exponent as a variable. But now that we've learned about logarithms, we have enough tools to be able to solve for it. So let's go ahead and try it out. The first thing is, I see that I have P's on both sides. Let's see if we can clean it up a bit. So if I divide both sides by P, okay, that cleans it up a little bit. We end up with 2, because these cancel out, is equal to, these cancel out, 1 plus 0.10 over 12 to the 12T, okay? So now we have 2 is equal to something to the power, okay? So what we're going to do next is we're going to clean this up a bit, okay? And so I don't have a calculator with me. We have 2 is equal to 1 plus 0.10 over 12, okay? So we're going to get I'm going to guesstimate that it's going to be about 1.010. You can double check that on your calculator, okay? Taken to the 12T power, okay? From here, what we're going to do is we want to ultimately solve for T, which is hanging out in this upper right exponent right here, okay? So eventually we need to bring it down, okay? And so the best thing to do is to go ahead and try to get it to the ground level, so to speak. And so we need to remove this number right here, okay? If we do so, we can go ahead by slapping on logs with that base, okay? You could do it that way, or another way you can do it is slap on base 10 if you want, or ln, and then you can move it to the front. Okay, so let's go ahead and give that a try. I'm just gonna go, we have so many options. I'm gonna just do log, okay, because that's the common and simple thing to do. So I'm gonna slap on log base 10 of 2, okay, is equal to log of base 10. I'm not gonna write that in. And you'll double check this number, 1.01. Let's just say 0.11, I don't know. All right, to the 12t. All right, and because of the power property, we can move it to the front. So we have log of 2 is equal to 12t times log 1.011, or whatever this number turns out to be, because you're going to double check it, okay? And so at this point, I'm going to go ahead, since I don't have a calculator, we can find log of 2 on our calculator. That's just a number, okay? So this is just a number on our calculator, okay? We can find log of this value in the calculator as well. That's just a number, okay? And then we also have this 12 in the front. So I bet you if you were to find log of 2 and log of this number, you can multiply 12 by this number and divide both sides and find exactly what t is equal to. So go ahead and finish that up and see if you can find the value, because at this point you only have one variable, which is the variable that you need to solve for, and you have enough algebraic techniques of multiplication and division and calculator support to find log to figure out what t is equal to.